With the eraser inserted about a third of the way up the tuning fork to dampen it, not only do we see that the resonant frequency has changed, but if I change the function generator frequency, and I'm going to do it now in tenths of a hertz rather than hundredths of a hertz like I did at the beginning, we'll see that the amplitude doesn't drop off as quickly. And that's telling us that we have a resonant peak with a smaller Q. We'll go back up in frequency, go past the resonance. We still have that phase shift, but not as sharp of a resonance. The gain phase analyzer takes a test signal, which is the pickup coil, and divides it by the reference signal, which is the drive signal. This eliminates any small variation in magnitude or amplitude of the drive signal, and it also allows us to look at the phase difference between the two. So I'm going to go ahead and do a sweep here. I'm doing a 100 hertz span with the resonance of the tuning fork at the center. So I'm starting 50 hertz below the tuning fork and ending up 50 hertz above the resonance of the tuning fork. What you're seeing right here are this ringing that happens when you suddenly turn the signal onto the tuning fork. The same thing that happened when we use the function generator. And then as you pass through the resonance here, this very sharp resonance, we get the same ringing here that happened before when we changed the frequency above or below the peak of the tuning fork. There's two ways to clean up this sweep and make it look better. The first is to do a slower sweep. So rather than doing it in 20 seconds like I just did, I'll do it in 200 seconds. And the second option is to zoom in on the peak. So first let's try a 200-second sweep. So you can see that by doing a slower sweep of 200 seconds, we've cleaned up the signal quite a bit. We got rid of the ringing here on the left side, and we've got a sharper peak here with less ringing on this side. But it's still not quite clean enough. And the really interesting data that we want is very close around the peak here. So instead of doing a sweep of 100 hertz, I'm going to do a sweep of 5 hertz. Okay, so here's a 5 hertz span, and you can see that the signal's a lot better, but we've still got a little bit of ringing going on here. And when you consider that the data that I'm interested in is the peak and the 3 dB down point, we can see that right here I'm already at the 3 dB down point, which shows you how sharp the resonance is. So I can do an even tighter sweep. I can do a span of 1 hertz, and let's try that. So here's my final sweep. I've done a 200-second sweep with a span of 1 hertz. And as you can see now, I've really eliminated all of the ringing that I had before, and I've got a good clean signal here. And now I can get my minus 3 dB down points, which are right about here, and then on the other side about here. Okay, so now if I put the eraser into the tuning fork about a third of the way up, and I go back to my original sweep parameters, which is a span of 100 hertz and a sweep time of 20 seconds, let's see what we get. And I'm going to go ahead and auto scale. And so what I see here is I don't get nearly the amount of ringing here and here that I got before. It's pretty clean. But let's go ahead and do a 200-second sweep and see what we get. So here's what our 200-second sweep looks like. And as you can see, it's cleaned up really nicely. There's no ringing. And in fact, you could use this sweep to get all your data. But since we're only interested in data very close to the peak, we'll go ahead and do a 5 hertz span. And here's our final sweep with a 5 hertz span. And the cursor showing the minus 3 dB down point.